Hi everyone, I'm Lulu B, a student at Syosset High School. I developed CookieCollector, a mobile game for Android. It uses AI to analyze users' input behavior and assess the risk of developing Parkinson's disease by playing a game. Parkinson's disease is a very common brain disorder among older adults. However, the current diagnosis method is costly and inconvenient as it requires clinical visits and subjective assessments. To solve these issues, I developed CookieCollector. As the player plays, a cookie randomly appears on the screen, and they simply tap it as quickly as possible. I also developed an AI model to analyze this movement data and suggest the player's risk of developing Parkinson's disease. It can quickly and conveniently detect early Parkinson's symptoms and monitor disease progression in older adults. Next, I show a user playing the game. A cookie will be displayed randomly on the screen. The player selects it as quickly as possible with the input finger. If the selection is successful, a green symbol will be displayed and a successful sound will be played. Otherwise, a red cross will be displayed and a failure sound will be played. During each game selection, the player will select around 40 cookies. After a user finishes the game, I developed AI models to analyze the input data and predict the risk of developing Parkinson's disease for the player. I developed the AI model based on recent published research showing a clear link between movement and Parkinson's risk. People with Parkinson's are significantly slower at touch-based pointing tasks than healthy individuals. I implemented two AI models. The first is based on motor control theory, specifically Fitts' law. It models selection time as a logarithmic function of finger travel distance and target size. We observe that selection times follow an X-Gaussian distribution, which captures both typical movements and occasional delays. Using this model, we estimate the probability that a given target selection duration comes from a user with Parkinson's disease. The second model is a CNN transformer-based deep learning model. It uses convolutional layers to extract local motion features in a transformer to model temporal variability across the entire input sequence, producing a probability that the motor behavior is associated with Parkinson's disease. The model runs fully on device using TensorFlow Lite, enabling low latency inference while preserving battery life and user privacy. A recent published research shows that the CNN transformer model is effective in detecting Parkinson's disease users' input patterns. It has an accuracy of 98% and an AUC of 0.97. I selected this model because of its high performance. This project is personal to me. My grandmother has mild Parkinson's disease and she now uses CookieCollector every day. She simply plays a quick, fun game on her phone and she can track her condition's progress without ever leaving her home. I hope this easy daily monitoring solution provides convenience to many more families and motivates us all to use technology to improve the lives of older adults in our community. Thank you.